Hello everyone, July 16th. Alright, let's finish this. And yeah, we have to do another method for this one. Alright, let's see. Add two numbers. You're given two non-empty linked lists representing two non-negative integers. The most significant digits comes first, and each. I remember this one. Add the two numbers, return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except the zero itself. So this would return this. Could you solve without reversing the input first? Oh yeah. Yeah, I mean, the way to do is reverse it and reverse it back. Could you solve it without reversing? I mean, recursion? How do you recursion to do this? I mean, it's very easy, right? If you reverse this too. But now the question is, can you do it without reversing the input? If I don't reverse it, then we still have to start from the end. I mean, I can walk this to the end. Huh, maybe. Great. Can we do this with recursion? Just like, this is the, we start with a start, right? And then we say, do we have a next one? If we do, we just move on to the next one. If we do, we move on to the next one. If we do, one of them do, we move on to the next one. So eventually, we'll go to a place where both are the last one. So we do that, and we create a node. And return, maybe, man, this will be so wild. Or you know what? I think we can do it. Let's do a two thing. Let's solve this one first, and then do the method without reversing. Okay. So this is reverse. Right, we'll reverse the input first. And for that, we need a reverse function. Right, we need a reverse function. And we'll return the reversed version. Okay, so we can say def reverse. We're gonna have a root. Okay, and we'll return a list node. How do you reverse it? Well, we have a dummy shall equal to list node, and next we equal to root. Reverse, and we have pre and current equal to dummy and root, and we say while current, I don't know, maybe it's while current, and then what? Reverse. We have a temp, and remember we have a temp is current on next, okay, and then current on next shall equal to pre, and pre equal to current, and current equal to temp. Okay, and the last one, temp will be none, so it'll be fine. This will point in here, and pre equal to current equal to none, and then come out. So pre is the end. And of course, we're pointing back to dummy, right? We're pointing back to dummy. So I need to cancel the dummy, which means dummy dot next shall equal to none. And then we return pre. That is reverse. Okay? So what we're going to do is RL1, RL2 equal to reverse L1 and reverse L2. Right? And then we say carry equal to 0. Okay, while RL1 and RL2, right? We need a dummy. Okay, dummy equal to this node. Don't call it dummy. Well, we need a dummy. And we say node equal to dummy. Right? So now we have RL1, RL2. And we say value will equal to RL1 dot val plus RL2 dot val plus carry. Right? And quotient remainder equal to div mod v divided by 10, and we say node dot next equal to list node value will equal to remainder, right? Value equal to remainder, and carry. Actually just do carry, right? And node equal to node on next. And RL1 equal to RL1 dot next. RL2 equal to RL2 dot next. Then we go do it again, do it again, do it again until let's say this one, right? We get this, and then node equal to node on next. Yeah, because node is here, right? Node on next equals something. Node on next. And then when we're done, node is pointing to here, and then RL comes out. Then we just say while RL1 v equal to RL1 dot val plus carry. Right? And carry R equal to div mod v10 node on next equal to list. Oh my god, it's exactly the same code. I have to repeat it 3 times. 3 times. Node equal to node on next. RL1 equal to RL1 dot next. And we do the exact same thing for RL2. Dear me. Right? Once we handle everything, then we do return, and then we reverse it. Reverse dummy dot next. Alright, let's give this a shot. See if it makes sense. Okay, seem to be making sense. Let's try it. That's exactly the same problem I had last time. Oh, I forgot to get the... Oh my god, I think it's exactly the same problem. I was about to say we probably have an issue. So when we're done, we just say if carry, right? Then node on next equals list node val equal to carry. I do not like it. Forgot about the carry at the end. Okay, so that was one way to do it. Don't forget the carry. OM plus N. Alright, so that's solution number 1. And now we're going to do something interesting. I want to do solution number 2. try solution number 2. Okay, so this one, the goal is without reversing the input. My idea is to use recursion, or basically stack, right? Or basically stack to visit the tail first, and then gradually build the answer list, right, from right to left. Interesting idea, right? What do you think? Well, add 2 numbers. What we've given us is this, right? Then we say if if L1 has a next, if L2 has a next, then we will go to the end. But when do we not go to the end? If neither has a next, right? Can be like this: if L1 dot next is none, and L2 dot next is none. Okay. This is the edge case, right? At the end. When that is the case, we are going to compute def solve node 1. Actually, it's not going to be optional. It's just going to be list node. Node 2 is going to be list node. And we're going to return a tuple of this node and carry, which is int. Okay. Then we say if both node, if node 1 has nothing, node 2 has nothing, we are reaching the end, right? Then we say v equals node 1 dot val plus node 2 dot val, q carry r equal to div mod v10, and return a tuple which is list node, val equal to r, and we return a carry. Okay. Otherwise, that means we are not somewhere, because we go this and we return to the previous some node, have node or this, right? Doesn't really matter. But if we start from here, we go, right? With this and this, and then we go to, and then this one go to the next one, and this one we do it again, okay? Then we return, and we need to return to the previous one. That is an issue. How do I counter that issue? That's like these two has to be the same length for this one to work. Can we do the same length? But you don't know the length at the beginning. So maybe we find the length first. Okay? We find the length first, and then we will add additional to the front. You know what? Maybe this one. Yeah, it's okay. So diff count, right? Node, and I'll return int count c equal to 0. Okay, Okay, while node c plus equal 1, node equals node.next. Then we return count. Okay. So what we want to do is c1, c2 equal to count L1, count L2, right? We say if c1 is larger than c2, then we need to add additional, right? We need to add additional. Then we say zero node equals this. Okay. 0 equals list node. Yes. And we go dummy, right? And while and k equal to c1 minus c2, we need to add these much. So while k node equal to dummy, alright, and say node dot next equal to list node, k minus equal 1, okay, and node equal to node dot next. Then try it again, try it again, try it again, until we finish. We added k nodes, right? We added k nodes. Now when we add k nodes, on the end we say node dot next equal to L2, right? And we have to have a L if C1 is smaller than C2. Okay, so we do this exact same thing. Okay, do this exact same thing. Dummy node C2 da 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 equal to L1. All right, so now we also need a star node 1. Okay, then we say node 1, node 2 will equal to L1. Node 2 will be dummy.next. Alright, and then here node 2 will be dummy.next and L2. Alright, so we fill them up, then we can solve. We probably can return we don't know yet. Let's solve it. So now they are the same, right? They're the same. We'll return this. Otherwise, right? Otherwise, we will do solve node 1.next, node 2.next will give me a next node carry equal to solve, right? Once I'm done, I do v equal to node 1 dot val plus node 2 dot val plus carry, right? I got a value, and we'll say return. No. What do we do? Carry r equal to div mod v and 10. To list node val equal to r next equal to next node, and return a carry. All right, so we're gonna say res and a carry equal to solve node 1, node 2. Then if carry is larger than 0, return list node val equal to carry next equals res, else we just return res. Alright, so this is like my attempt of not reversing them. Is this one right? Oopsie doozy. Count. Oh my god, I turned C. My bad. Local value, node 1. If they're the same. Oh, shoot. You know what? I'm just... L2 equals this. L1 equal to this. Then we just do L1 and L2. Looks fine. Try this. That works. Alright, let's see. So a couple of things to see. First of all, I want to see my previous solution. But to make recursion work, I need to first fill in zeros to the left of the smaller linked list. Yeah, there might be a better way to do this, but I'm not sure. Alright, so 2020. A long time ago. Alright. Do we have the same number of test cases? 1563. 1560 is the same. That one, hold on. This is the original one. What the hell? Wait, hold on. I think I didn't do it too fast. Alright, so this is the 3 years ago. Okay, 3 years ago. What was this? The hell are you doing, man? I did a sum str. I was trying not to reverse them. So, man, that is not. It basically copied the thing out. If you copy the thing out, why don't you just copy the thing out as a number? Why do you do this? Right? Why do you do this? It's so stupid. It is so stupid, man. It's so stupid. I don't like the solution of my previous self. Alright, how about this one? What is this one? This one's reverse. Count, reverse. If I reverse them, why do you count them? Alright, why do you count them? I don't need to count them when I do the reverse. That was bad. That was bad. Well, that means I have improved. Now let's look at a solution. Using a stack. I mean, if you use a stack, then what's the point of using a stack? Well, are you telling me put everything into a stack? Oh my god. Oh my god. This is so useless. If you're doing this already. If you're doing this already, right? Oh man. Reverse linked list, yeah. Alright, so that will be it. That's it. And let's go back to this problem. That was 2 days ago, right? Sufficient team, and the solution is DP with, I mean, in my case, this works, but it's not good. The previous solution should be this, I remember. So what I'm trying to implement here is going to be the solution DP without Wait, is that the one? The DP without binary search? I don't think I needed the binary search. Hold on. Is this one 1751? No, it's 1125. 1125. This one is just straightforward DP. I'm using a prefix sum. So hold on. I need problem 1125. Yep, that's the one. Smallest sufficient team. Right, and for this I use wait, is this the one? No. Hold up. This is the one. I don't remember, man. I remember it's the one that we don't need to use binary search. Did you use binary search on this one? Oh, yes, it's this one. Nah, you're wrong. It's not this one. Not 716. Probably 715. Probably 715. Let's see. 715? Yes. So, here's binary search. Right? Binary search. I sort the whole thing. Right? I sort the whole thing. And then start and end. I store the whole thing, and the state shall be max value attainable doing events. Oh, I have to get back into the mindset of this problem. Right, I have these events. If I sort them, okay, and I remember the answer, we sort based on the starting, right? Sort based on starting, okay. We sort based on starting. And the question is, the maximum score, the maximum value I can take. If I take this, right, I take the current event with a count. Right, I take the ith event, the index event, with the current count with the previous ending time. That's the DP, right? That's the DP. And what I want to find out is if I take, yeah, so basically what we're trying to say is if I take, right, so DP will be this. DP is index and count, right? That's DP, but a DP function requires another one. So let's do another one. DP function requires, underscore it, the previous end, right? So basically, index and count, and what we want to try to find is the max value, right? The max value when taking events index as the count event. And we use a pre-and to determine whether it's possible. Okay? So if this has been done before, index and count have done before, which means we have some previous event, like in the past, that allowed this to happen already, right? Allowed this to happen already. Then we don't have to keep computing, right? There's no point. Keep computing. Again, so this previous end itself is not, it is not part of the state. Like all we want to find is, give an index and count what's the largest value you can get. And to find the largest value you can get, taking this event, Actually, it should be starting from this event, right? So starting from this event. Starting from this event with a count. So we can take this event, right? And take this event and take the next event, right? Or we can not take this event and we take the next event. Right? Because we have two possibilities. One is I take index and then count. I take it, right? If I take it and whatever. So what's the result? Yeah, if I take index count, what's the largest we can get? So I can choose to take this, right? Or I can choose not to take it. If I not to take it, I'll just do the next. If I take it, I'll do the next as well, right? So as we go through the whole thing, we're starting from the first one, right? We say we take this, or we don't take it, doesn't really matter. So we go through the entire thing, and the result to return is go through the DP, find different index starting with a count. That seems to be okay. So let's try. Let me try this. So this is inspired by the official solution without binary search. We use DP, where DP index and count and previous and is the max value possible, right? Taking events index, okay, taking events index as the count event with the previous event ending at pre-end. However, pre-end is not part of the state, right? Because if index count has been handled, right? Because if index count have been handled already, it does not matter, right? It does not matter the exact value of previous end, right? The sole purpose of pre-end is to check if events index can be taken in the first place, right? In the first place. Thus, this DP is still 2 level, right? 2 level, not 3 level. All right. We need a, yeah, I'm gonna use default dict for the DP. I say DP equal to default dict int, and what? Events dot sort. Okay. Then def dp, we have index, count, index count, and previous end will return an int. Hold on, gotta feed my cat.
Little finger. I can't do this. Pinky. What did I say? Little finger. I mean a pinky. Jimbo, get off. Come. Come on. There. A little butt massage and Jimbo off. Put that in the notes for the cat sitter. If Jimbo stays on the counter, just give him some butt massage. Imagine we write in the requirement, breakfast. Jimbo needs 62.5%. I'll leave it as an exercise for the cat sitter to figure out how to get 62.5%.
Yeah, microwave water for 15
seconds. I probably need to put the volume. Actually, probably about a quarter cup of water. Yeah, we're gonna be very specific. Yeah, I like to put it this way. How to get 62.5% and leave as an exercise for the babysitter, the cat sitter. That could be our interview question. No? The requirement to babysit our cat, the cat sitter our cat, is to figure out how to get 62.5% without using a measuring cup.
That might be too difficult.
Right, need to be on the same intellectual wavelength as our cat. All right.
Alright, let's DP this thing. How do we DP it?
That's 5/8.
You know what? I would like to do lambda -1. Okay. So we need n equal to len events. So of course, count. If index is equal to n, right? Or count is larger than k. Because count starts with 1. Okay. So when that happens, I think dp index count equals to 0. It's just nothing. Now return 0. Otherwise, we can not take. Okay, we can say option 1 is dp index plus 1 count tree end. So this is not take events index. Option 2 is not take, we can always do that. And option 2, what if we cannot take? Well, I mean, if it has been handled before, right? So if dp index count is larger or equal to 0, then we just return dp index and count, right? So this is already handled before. Or just don't do it again. Otherwise, I'll choose not take the events, okay? Or I can choose we try to take the event. And to take the event, it has to be if events index, the start has to be larger than previous end, right? Then we can take the event. Take events index. Else option 2 shall equal to 0 because we cannot take it. So once that happens, does it make sense? Already handled before. What if it handled in the past is a bad one? What if that already handled before? Okay, so like doesn't really matter. Take it, this is already handled, which means it can be taken previous, so it's already taken. Yes. Yes, but if it cannot take, if this event we cannot take, then I should not not take. Yeah, this is to take this one, right? We have to take this one. Then where does the not take place? Because dp index count is to take this, right? To take it, we have to take it as the count. Right? We have to take it. Or we can say, starting from this, what's the maximum? Starting from this, what's the maximum? So it's not taking possible, max value possible, starting from as count event. And I can choose not to take it. Then we go to the next one. Or I can choose to take it. But to take it, it must be possible. If it's not possible, then we cannot take it. Right? Then we cannot take it. Okay, so if it's possible, that should be dp index plus 1. I'll take it. So, but this will be count plus 1. Alright. Previous end is going to be events index 1. Okay, I mean this plus events index 2. That's option 2, right? And then we can say dp index count shall equal to the maximum of option 1 and option 2. So what we can do is this if it's smaller than 0. Okay. Then we do all of this and we'll return this. Right, then we do dp 0 count is starting from 1. Pre-n is -1. Okay. Actually pre-n probably we can do 0. Yeah, pre-n we can do 0. So we do that. Hopefully we'll handle all situations. Right? So what is, then we say return for I in range n events dp n I. So ith event is the first maybe k, and we take the maximum. I'm not sure at this point. I'm a little bit confused. Yeah, it doesn't make any sense. Oh, don't call it dp here. This should be memo. Memo dp this, memo, and this will be memo. Nope, doesn't make any sense. I think I misunderstood the whole process. Damn. Yeah, I thought I understood the solution, but turns out I did not. Answer should be 7. I don't see any 7 here. Look, 0 as the first one, right? And 2, who as the second one? 0 as the first one. How about 1 as the second one? I don't even have 1 as the second one. I have 0 as the first, 1 as the first, 2 as the first, and 3 as the first. We don't have a 3. 3 as a second, 2 as second, 1 as a second. Hey, oh, it doesn't make any sense, huh? You know what? For one thing, I like to start from 0. And this shall be k minus 1. Right, 0, 0, 2, 0, 3, 0. That doesn't make any sense, right? 0, 0. I'm at 0, so the 0th event is the 0th count. Okay, so that will be 4. I can try to do this. Yeah, how many events left? Count events left. Events left. You know what? Hold on. I gotta rethink about this.
Oh, thank you. Beautiful. not able to throw away the trash tonight, so I have to wait for tomorrow.
Why?
Because it's all full. Last night was already difficult.
Congratulations for what?
Oh, thank you for finishing the feeding process. See? You helped a lot.
All right. Oh, it was not right. Let me rethink about this. And we should be starting from with the remaining instead of doing count. Maybe how many remains, right? Starting from here, but how many remains? Okay. And then we say if 0 remain, then we do 0. Otherwise, we can do this, how many remains, or we take this and we go to next. How many remains? But I don't understand. Well, I have 0, 0, right? 0 is smaller than 0. Then not take. So these are all not take. This is all not take. And they're all bad. And then this larger than pre. That's true. Then I shall do this, which shall be 1. And count plus 1 shall be 1, 1. Right? I shall have a 1, 1. If I do a 1, 1 with previous events and, okay, should be and a 2. The index is 1. Right, because I sorted so this and this and this. And it's bad. Right? It's bad. But I shall have index plus 1. I shall do a 2, 1. 2, 1. Okay? So 2, 1 comes in. Count is not equal to k. Okay? So 2, 1. And index is 2, which is not equal to n. So say this is smaller than 0, right? And this will be 0. So because that will be 3, 1. 3, 1 will be 0. So we do here. Previous and. Previous and, because it's this, so previous and should be 2. Right? Which means the current start shall be right. Then it will be 2 shall equal to this, or plus 1. That shall be 0. And events, there shall be 3. Right? That shall be 3. So this shall be 3. I don't understand. I don't understand. Hold on. Let's call it remain. Okay? Remain. If remain equal to 0, which is smaller equal to 0, nothing remains, right? So we do this. We say remain. And if this remain, then remain minus 1. Okay? And then this will be remain, and this will be remain. So remain will be k. I have k remain. And we shall say k remain. Okay? So now what we want to do is probe this thing. Okay, probe this thing. So credit index remain pre-end and op1, op2. Right, index. What I want to find is index 2. And this events is going to be this index 2. Is this with 2 remain. With 2 remain. Option 1 and option 2 is 3. That's correct, right? This is correct. And index 2 with 1 remain. Pre-end is 3. That is not happening, right? That's not happening. But we should have an index 2 with 1 remain. We shall have a pre-end as 2. But I don't have that. Interesting. So we start as 0 with 2 remain, okay? We start with 0 with 2 remain. And pre-end is 0, which is fine. And option 1 is, I skip to this, that's 3. Perfect. Option 2 is wrong. Option 2, so this is index is 1. 1 with 1 remain. Okay, 1 with 1 remain with the current end, which is 2. So 112, right? 112, this one. 112 give me 0. 112. 112 I can do 212. Where is 212? Exactly. Where is 212? Where is 212? Do we even have a 212? Print index remain pre-end. I do. I have 212. I have 212. And then where did it happen? Do I still have 212? I do. So 212 is fine. Do I have 212? I do not have 212. So 212 at some point has happened before. Wait, hold on. How is that possible? One two is here. Okay, 212. Mammal index remain. 212 is 0. Why 212 is 0? Who said 212 is 0? Who said 21 is 0? Because 213. I see. Because 21, we hit 21 before, right? 21 and before is 3. So I need to change that. Right? Option 1. In fact, if I cannot do, I shouldn't even do it. Right, if I cannot do, I shouldn't even do it. Then what I'm supposed to get the value? Maybe I should just leave it as 0. Let's try leave it as 0. Okay. If I leave it 0, I just return. Okay, and then if it's if not, right, which means we haven't tried it yet, then we say not taking it. If we do this, and we do this, would this work? This one will work. Yeah, this one will work. You will have to, like, you try to put it in 0, because if you take this, if you can take whatever, it will be definitely larger than 0. Now it makes sense. Does it now count? Remain. Starting from then, with remain number of events to take. And the previous event ending at this. Having handled already, it does not matter the exact value of pre-end. The sole purpose of pre-end is to check if events can be taken in the first place. Yes. So that, hold on, this is going to be O mn plus n log, wait, hold on, O k n plus n log n. Oh, that would take some efforts. Try it. Eee, that was ugly. That was ugly. Alright, what did I do wrong? What did I do wrong? Oh, one thing we don't have to do, I can just do this. Then this will equal to maximum, this or this. Yeah, this won't change anything, but yes. It won't change anything, but let's make it cleaner. Alright, I don't know. I'm gonna take a look. What did I do wrong? Without binary search. I use count. I think I didn't do this one. Hold on. Current index, taking this as the largest with the count and the previous ending time. If current is smaller, so you cannot take it, right? You cannot take it. So you take current plus 1. Okay. If you can take it, if it has not been taken before, or then you try take this or take this. So if we translate this, what are we saying? We're saying we're taking from this with the remaining, okay? And this. So I think here is if events index 0 is larger than previous, no, if it's smaller or equal to previous end, then we shall return dp index plus 1 remaining and preend. Right, so this cannot take events index. Otherwise we can take it. Then we say if not, then we do not take or take. Oh, this is the key. This is the key. This is the key to this, to the solution. but I'm pretty sure probably I return this one will work as well. Yeah. Max value possible starting from events this. Right, starting from this with the remaining number of events to take. So it's starting from 0 with k. So that's the entire thing. What's the maximum you can take? So this is the key. Yeah, now I think about it, it does make sense. If we cannot take this one, right, and we're trying to say starting from here, then you can't. So you just immediately take the next one, right? If you can take it, then you have two options. You either do this, right, or you do this. Then we don't have to do this because we already know it can. Oh, then we can immediately, so I can just do maximum of this and this. Don't have to check again. Right. We can take, we have two options. Take events index or not take it. Right. If we cannot take events index due to the conflict in time, we simply skip it. Don't even put that into the DP, into the memo, right? We don't even put that in. We just skip it. If we can take it, then we try to take it. It's correct. Okay, so yeah, that would be it. It took a while to handle this one, but that's all right. All right, I'll see you guys tomorrow.